This is the introduction to quadrilaterals. So quadrilaterals are four-sided figures. So quad means four, lateral means side. If you're moving laterally, you're moving side to side. So quad, again, four, lateral sides, four sides. These four-sided figures can be, they can look like our conventional four-sided figures. Or again, if you notice this figure, it does have four sides, but it crosses. Okay. So there's complex quadrilaterals. There are convex quadrilaterals. There's all sorts of different types of quadrilaterals. We're going to focus primarily on 7 special types of quadrilaterals. Okay, so most of these aren't going to apply to what we're talking about, but it's good to get a good overview of what quadrilaterals are. So they could be any shape you could possibly make by making 4 lines that all connect. So two-dimensional means it's on a flat surface. Okay, so 2D is just up and down and left and right, so just 2 directions. So we're in a two-dimensional flat surface like a plane, that we graph stuff on, XY plane, or any flat surface is our 2D surface. Closed means that they all, we have 4 vertices on a quadrilateral. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So closed means all the lines join up, they meet at vertices, and the sides are straight. So again, it doesn't matter what shape you make, as long as you fit these criteria, you have a quadrilateral. 4 sides that all meet up at vertices, right? So it's not open, right? And those sides are not curved; they're just straight lines. Okay. I wanted to change the slide on. Cool. Okay. So properties. Again, 4 sides, 4 vertices. Okay. We also could add to this that they're straight. 4 sides, 4 vertices. The vertices all meet up, and they're made by straight lines. And then the additional one we want to talk about here is that the interior angles add up to 360 degrees. So triangles, we talked about how the triangle sum theorem said that triangles, the interior angles of a triangle add up to 180 degrees. Here in a quadrilateral, they're going to add up to 360 degrees. So if we take a quadrilateral, okay, and we put a diagonal on it. So this is called the diagonal. It goes from one vertices to the opposite vertices, right? These are considered consecutive angles, consecutive vertices, right? These are consecutive vertices. And then the opposite vertices, right? So if the diagonal goes from one vertices to the opposite vertices, or from one angle to the opposite angle, that's going to be considered, that's the line that's made there is the diagonal. So if we take a diagonal, we notice we have 2 triangles. Okay, we have 2 triangles. So what are these 3 angles going to add up to? Okay, those 3 angles are going to add up to 180 degrees. Okay. What are these 3 angles going to add up to? These 3 angles are also going to add up to 180 degrees. Right? So if we add this angle plus these 2 angles, plus this angle and these 2 angles, all 6 of these angles added together, we're going to get 360 degrees. So the 4 angles, right? If we consider these to be one angle, we consider this to be one angle, we know the 4 angles of the quadrilateral are going to add up to 360 degrees. So it could be any quadrilateral, even if it's a square, okay, or a rectangle where all the angles are right angles. Right, 90 plus 90 plus 90 plus 90 is 360. Or if it's a non-conventional or non-standard quadrilateral, all the sides are still going to add up to 360 degrees. And then for our purposes, we have 7 special cases, 7 special quadrilaterals that we're going to talk about and focus on in our class. Okay, the first is a parallelogram. Okay, we'll just go kind of through the definition first, and then we'll get the reference sheet up, and we'll look at that with the diagrams and all the properties. So parallelogram, quadrilateral that has two pairs of parallel sides. So typically drawn like this. The arrows again represent parallel sides. So it's defined by its parallel sides. We're defining a parallelogram as a quadrilateral that has two pairs of parallel sides. So four sides and two pairs of parallel sides. The opposite sides are parallel. The other three on here right now are rhombus, rectangle, rhombus, and square. Rectangle, rhombuses, and squares are all parallelograms because they all have parallel sides. So if we draw them out, here's a rectangle. Okay, we know these sides are parallel, and these sides are parallel. A rhombus. Okay, we kind of draw a rhombus out. Again, we know parallel. Right, the opposite sides are parallel. Then if we draw a square, we know opposite sides are parallel. So rectangles, rhombuses, and squares are parallelograms because they're quadrilateral, right? They have four sides. They're quadrilaterals, so they have four sides. And two of those sides, two pairs of sides are parallel to each other. So they are parallelograms. So a rectangle is a parallelogram. Okay. What defines a rectangle are the four right angles. So a rectangle has four right angles. So if you ever see a four-sided figure with right angles, you know it's a rectangle. Okay, you also know it's going to be a parallelogram because you know rectangles are parallelograms. Okay, because two sides are also then end up being parallel because they're right. Eventually, right, we would do the converse to the same side interior angle theorem, right? So if we knew we had right angles and had a rectangle, since the same side interior angles are supplementary, we could then show that these lines are parallel, okay, and then we can show that these lines are parallel. So if it's a rectangle, you're going to have a parallelogram. We don't need to worry about the proof or anything like that. We just need to know that rectangles are defined by having four right angles. Parallelogram is defined by having two pairs of parallel sides. Okay, rhombus is defined. Again, the sides are parallel, but I don't want to confuse anyone. So let's have our figure, our rhombus. A rhombus, again, is a parallelogram because we showed the two sides were parallel. Right? These two sides are parallel, and these two sides are parallel. Two pairs of parallel sides. Okay, but it is defined, okay, by four congruent sides. And if all the sides are the same, then it is a rhombus. So it is defined by having four congruent sides. That's what defines it as a rhombus. So if you have a four-sided figure, a quadrilateral, quadrilaterals are four-sided figures. If you have a four-sided figure where all the sides are congruent, you have a rhombus. And we know if it's a rhombus, it's going to end up being a parallelogram because all rhombuses are parallelograms. And we're not going to go through the proof of that or anything like that, but that's going to be the case. The proof is good because you would have, you draw a diagonal in, and then you, by reflexive property, you would have, by side, 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 those two triangles would be congruent. You can get opposite angles would be therefore congruent by the corresponding parts of congruent triangles. All right, and then you could also have these angles, which would then end up making these supplementary. Then again, you would have same side interior angles that are supplementary, so the lines are going to be parallel by the converse to the same side interior angle theorem. But again, as fun as that would be, we don't have the time for that. Okay, and then square is our last one. Square is defined, okay, by having four congruent sides and four right angles. So again, let's get rid of, again, we have parallel sides, so let's not worry about that. Okay. Again, let me get rid of the parallel lines on the rectangle too. So a square is defined as having four right angles and four congruent sides. So if it has four congruent sides, it is a rhombus because a rhombus is defined as having four congruent sides. If it has four congruent angles, then it's a rectangle because a rectangle is defined as having 4 congruent angles. So a square, by definition, right, because the definition says 4 congruent angles, 4 right angles, 4 congruent sides. So since we have 4 right angles, rectangle. This is a rectangle. Square is a rectangle. Since it has 4 congruent sides, a square is a rhombus. Okay? So a square is a rhombus and a rectangle by definition. It's defined by 4 congruent sides, 4 right angles. Okay? The rhombus is then defined as having the 4 congruent sides, and the rectangle is defined as having the 4 right angles. So if you have 4 right angles, you have a rectangle. 4 congruent sides, you have a rhombus. 4 congruent sides and 4 right angles, you have a square. And again, all of those, there are proofs that could be done that show that they have 2 pairs of parallel sides. So if they have 2 pairs of parallel sides, they are a parallelogram. So all of these are parallelograms. So those are the quadrilaterals we're going to talk about that have 2 pairs of parallel sides. Okay, the other categories is we can have 1 pair of parallel sides. All right, for our purposes, we're going to define trapezoids as having exactly 1 pair of parallel sides. This is not my favorite definition. I like the definition of having at least 1 pair of parallel sides because it makes everything more fit together better. Like we can include, it makes our Venn diagram, so we'll see our Venn diagram from the reference sheet. It makes our Venn diagram much more interesting when we have a trapezoid defined as having at least 1 pair of parallel sides instead of exactly. And you'll see it both ways, but for our purposes in this class, we're going to stick with this definition, which says exactly 1 pair of parallel sides. So our trapezoid would look something like this. Okay. So these 2 sides are the base sides. We're going to call these the base sides. The base sides are the sides that are parallel. And then we'll call the other sides the legs. Okay, so the parallel sides are called bases. So these are our bases, and these are our legs. Okay, you can't see it that well, but this is the base. Base and base, leg and leg. So trapezoid is defined as having exactly 1 pair of parallel sides. So an isosceles trapezoid is it's a trapezoid. Okay, so and then it's going to have extra information. Okay, the extra information it has. Let me draw this. Shouldn't have elongated it. Right. The key here is not size. The key is that you have 2 pairs of sides that are congruent, the non-parallel sides, which are the legs. So the non-parallel sides are called the legs. So these are our legs, and these are our bases. Bases. So bases and probably should write neither. Legs. These are bases. So again, trapezoids. These are both trapezoids. Okay, trapezoids are defined as having exactly 1 pair of parallel sides. An isosceles trapezoid is a trapezoid that has a pair of legs that are congruent. So it has the legs that are congruent. A kite is a quadrilateral in which 2 disjoint pairs of consecutive sides are congruent. So we have some vocabulary words in there. Okay, let's start by drawing a kite to the best of my ability, or at least a decent kite to somewhat of an ability. Okay. Right. So this is what defines us as a kite. So disjoint means that you can't pair these 2 and then these 2 together. Right? It tells us here. Disjoint means a disjoint pair means one side cannot be used in both pairs. So we can't use this side as being congruent to this one and this one. You have to just pick one and the other. So you have 2 up here, 2 down here. They're disjoint. They don't flow. Right? There's joint, like joint. Joint. They're joined together. Right? So join. Right? We join the sides together. Disjoint means you can't join the sides. Right? So you have to just go with the consecutive side, right? Consecutive means right next to, like 4 and 5 are consecutive numbers. 5 comes right after 4. 4 comes right before 5. So right next to each other and disjoint. So right next to each other and disjoint, which means we can only go between these two. Instead of going here to here and then here to here and then here. Okay, disjoint is kind of a difficult concept to explain, but I hope that's good. Okay, so that's introduction to quadrilaterals. Again, we want to start from the basics and build up from there. Right, well, we're going to talk about 7 special cases. So quadrilaterals are 4-sided figures. Quad means 4. Lateral means side, so 4 sides. And we're only going to talk about 7 specific cases, which were our parallelograms, rectangles, rhombuses, and squares. Right, all 4 of those are parallelograms, and then our trapezoids, isosceles, trapezoids, and cuts.